Okay, I'm recording from now. Yeah. Okay, good morning. As I told you last week, today we are, or at least myself, is quite excited for today's class. We have a guest speaker. As I told you, he graduated in. When did you graduate, Xavier?
2017. Hold on, my Google Assistant's going on.
Yeah, 17. So that's about 7 years ago. Yeah, been a while. And actually, I think between 5 to 10 years, that's a good time for them to coming back to give a talk. Because if we invite someone who is older than that, who graduated before 10 years, what they can share with you could be quite different from what Xavier can share with you. Okay. So anyway, let's welcome him, for his presentation.
Oh, yeah. So first of all, I think you can see me all right. Okay. Thanks for having me here, Professor. I always appreciate coming back to speak with students and share kind of perspectives, and hopefully they get something out of it too. Yeah. So a little bit about me. My name is Xavier Collantes. So for the last less than a year, says a year here, but less than a year, I have been at a startup called Belva. So it's an AI startup. So basically the whole thing is serving the legal world in terms of using kind of the newfound technologies we have in artificial intelligence. And so my role is a software engineer. So I actually went to Gonzaga and as a business major, an MIS concentration, and a computer science minor. And right out of the gate, I ended up at JP Morgan as an analyst, going heavy on the business route of things. And that didn't go very well for me. It wasn't for me. And it's a good thing that I found that out right away, because I even at Gonzaga, given what my degree and what I was studying, I was kind of in a crossroads of, do I want to do business side of things? I think that's pretty interesting. Do I want to do the technology side of things? Do I want to, and I felt like at the time, and this is kind of correct in some sense, and we can get this into later, but I wanted to specialize really hardcore in one or the other. And so for me personally, working in finance wasn't really for me. So I'm thankful for the experience that I had. It was a tough one, but it was good to get that out of the way so I can focus on what I really wanted, was the other thing, which was technology, programming, and becoming just a full-on software engineer. And that took some time to do that and to learn and get on as many projects as I can. So that was 2 years JP Morgan, and then after that I came over to Google as a vendor for about a year or so, and then became a full-time. And so when that happened, I was working on kind of like 75-80% software engineering, and then the other 20% would be kind of program management. And so I don't know if you all know what program management is. So basically what that means is you have like a kind of like an organization or a group, and you're a project manager for them. You create goals, you work with the stakeholders. You basically push the efforts and smaller projects in that organization along, in service of either users outside the company or within the company. In this case, it is within the company in Google search. And so, for example, those features you see when you, I think I actually have, see, maybe hop to it real quick. So these features are what I worked on back in the day. So the quality and the algorithm, the grammars and internationalization for a feature like this to show up when users would search for it is what my team worked on. Cool, yeah. So that's and then at Belva AI, we work basically. I work as a software engineer using a lot of Python, building a lot of these agents and LLMs to work with. Basically, you consult with it, and it'll help you with your tasks. But before we start, I kind of want to get, and I know it's kind of hard because I'm not actually there, so this is kind of a challenge. I kind of want to get from students like, what do you, this is from what I understand, BMIS 3042 and machine learning. What are some, maybe 1 or 2 answers out there of students? What are you looking to get out of the class? Maybe a professor, you could call him out for me or something and have him speak.
So I am also a computer science minor. So in the School of Engineering and Applied Sciences, I learn all about computers and stuff. And in this class, I want to see how I can apply computer stuff to the business world.
Got it. Got it. Good. Okay, that's great. Great. Thank you. Thank you for sharing. If there's no one else, I can continue. Yeah.
Yeah, I'm studying MIS alongside finance, and so I'm interested in just gaining like some more technical knowledge and being able to communicate with like IT departments better.
Great. Okay, that's awesome. Yeah, thank you. Okay, cool. And all right, let's continue here. So there's 3 parts I want to go over, and we'll touch on those points there. Kind of give you an idea of my background in what I've used data analysis, machine learning for, go over kind of the essential tools for this industry and where the industry is heading and how you as students in school can better prepare yourself for the world out there. So the data analysis part, right? So this is a concept I just kind of want you to kind of have in your head while we go through this, is it'll kind of help you visualize where things belong. Hopefully my little person isn't blocking the screen here. I'll move around and stuff, but basically this concept exists. I think we even went over this, a version of this in MIS. Basically the data funnel, in the sense that there's a lot of data out there. You hear stuff like big data, we're gathering all this data, blah, 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 data, this. The core thing that I at any job, either in the finance world or in software engineering or the machine learning stuff or Google, whatever, the general common denominator there is that you're taking a bunch of data, which is just in different formats and just lying around, or you got to go gather them. The challenges come from gathering the data, turning it eventually into something that's actionable. And I use the term actionable because if you have like a dashboard or a machine learning model and you create this cool thing, and then you show it to your superiors, right? Your managers, the VPs or whatever, what good is it if it's not going to improve something in the business itself? And so there's a lot of things out there that I hear about, like startups and stuff, where they're building really cool stuff. And the problem that they have is that they have a technology but no use case. And so it's almost like that's the second hardest thing, is building the thing itself. Cool, you have it, but applying it to something that's useful and then getting users on it, right? In their case, getting inside of an organization, you're trying to get buy-in, justification, proposals, and stuff like that. And so that's kind of the process, the common thing that I see in all the positions I've ever held. So again, we have the big data stuff, we have the logs, the metrics. All that stuff is going to come in different forms. And so you have to use tools to clean it up, dedupe it, marshal it into data types so that it can be used downstream. Because if you're in a big corporation or in an organization at all, you're just kind of like a section of this funnel. You're typically not the whole thing. The more that you can master of this funnel in terms of the tools and strategies and techniques, the more useful you'll become and more marketable you will be in the future. But typically, as you start out, you kind of just stick yourself in one of these levels. And this is true for data engineering, for data scientists, for analysts. We'll go over that in a minute. So the idea is that you clean the data, you have to store it somewhere, and then you can use that data, turn it into dashboards, or the trend nowadays, I guess. This has been around for a while, but now it's getting kind of on the front page of the news here, is training those ML models, right? And then that's pretty resource intensive. So there's a lot of techniques to go about that. And so that in itself is its own kind of funnel, it really, because you can take, deciding on what technology you want to use for your use case. You want to train your own model, you can use a base model, you can use RAG models, different techniques. And then you use that and you turn it into something that the user can use, usually a non-technical person. In the case of machine learning, like with LLMs, you can do fine-tuning or prompt engineering, or again, RAG models, where you have a vector database and you insert stuff into your prompt so that it's faster. And then at the end, there's always going to be the actionable data. That part is, I think, often left out. And so as like MIS, something that the concentration focuses on, that versus like a computer science, right? Like someone who was speaking earlier, he kind of did what I did. The MIS concentration focuses on more of the kind of front part of this, the bottom part, I guess, of the funnel, because you're presenting the data, you got to use justification for it, you got to like have it locked into the business itself. Whereas the data engineering, computer science stuff is kind of on the top part of the model where they're building the infrastructure around it. So just to review, yeah, so this is kind of features I worked on. This is pretty cool. I mean, the amount of users that would click on this, especially during like March Madness, is insane. It's in the, you know, millions. So it's kind of cool that I worked on that. So it's kind of a proud moment for me to show that on there. But for Google, right? So what I did was a lot of it's search quality. So gathering a lot of what the metrics came through, being able to say, hey, where are there opportunities for us to focus our time and energy and money, and how do we go about those strategies? And so what I specifically worked on was like the grammars for the languages, right? So I don't know how many in the room speak a different language, but in case you don't, what happens is that you can't just translate things into one language to another, for example. And so you kind of have to tune your feature to work in all these different locales. And so you have things like context-free grammars. This is really like nitty-gritty stuff in terms of like machine learning. Kind of an older technique. Basically, you just have like a rule set, and it's basically, if you think about it, like you have the rule set, and then you have like a phrase or a query, and then you take it and you split it up, you tokenize it, and then you see where it fits in like the grammar. And so it's kind of like a fixed order specific technique. But one of the big things that I learned, I touched on it, I think in some class when I was in college, but we really used every day was like precision and recall, because we're quality metrics, right? And so if you think about it, so just kind of an overall view of what those terms mean. Precision is like, so recall is like actually it's high like capture, you capture more things, but they're not necessarily going to be right. Precision says how many of those things are correct. So for example, the way that I type sometimes could be high recall because I hit a lot of the buttons, but a lot of them are always misspelled. So I'm getting more words out. So it's a high recall, but the words are always messed up. Like they always got to spell check them. So that's low precision. So a high precision would be, I'm getting many of the words like correct. So kind of a super general, just quick touching on what that is, but that's a super important concept, I think, if you go into machine learning and especially testing and quality, because those are the languages, the part of the vocabulary you use for comparing models, which is super important. So at the Belva startup, so it's like a 20-person, there's 2 backend engineers, myself and another one, and this is really code heavy. It's not like my job at Google where we're considering the business case. This is more like code all day, every day. And I've gotten very good at it, at least better than I was before. So I'm happy about that. But in this case, this is kind of totally different because now we're using local large language models. And so kind of what you hear a lot with ChatGPT, a lot of these startups don't train their own models. They're actually using it as a base model and then building on top of it, either calling it as an API or like hosting it, a really small model, depending on the use case. In this case, it's because it's a startup. A lot of it is like just using like the existing models out there, and then building on top of that because it's cheaper, it's faster. But eventually, what you want to do is you want specific use cases and a higher quality for that use case, and so you end up training your own models and so forth. And so that's pretty fun. One slide I don't have in here, but since somebody brought up talking about finance, is at JP Morgan. And so from a data perspective, the machine learning there, as you can imagine, like it's not on the cutting edge whatsoever, right? And they actually have some very basic flaws in terms of their infrastructure that I found out from. I wasn't a data engineer at all. There actually I was as an analyst, right? So totally different, totally all business finance stuff. But I did have curiosity in terms of, I reached out to some data engineers in the bank and said, hey, why are things like this? And they're like, oh, we just didn't, merge databases, blah, 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 stuff like that. And it's like, and so there's certain pain points that come to the non-technical people because infrastructure is not very good. And so there's certain challenges to what that basically ends up for people downstream. But a lot of that from articles I've read, they've come a long way in terms of like embracing a lot of the technologies out there. It just takes a lot longer to do it. And a big part of it is like also, again, like I said, the buy-in. It's not good enough to have good technology. You also got to convince other people to use it. That's the kind of business side of it. That's actually, to me, more challenging than the actual technical part. That's personally, right? So MIS people are very good for that, are very good in terms of training for that, because they understand where a lot of those use cases come from, right? Like you have accounting background, you have finance background, you could say, oh yeah, like your accounts receivables are like all messed up like this. Well, there's a technology that can be married to it. And so I was put in a position that was quite interesting because I eventually become a software engineer where a lot of these people are not like that. So they're kind of ideas that I saw back then that was like, that I'm learning now. I'm like, that could have been good for that, So that kind of thinking is what I think excited me, and it does excite me about like kind of in relation to MIS, BMIS. So I just want to go over tools of the trade here in terms of what's important, right? So again, we're going back to the funnel. And so common, again, these are just a short list. There's like a nearly infinite list of tools you could use, but these are just the kind of the big ones that, as students, I feel like would be really useful to know, or at least be familiar with if you were like in an interview or on the job. Google Analytics, that's pretty commonplace in terms of any kind of website that people build or any even applications. It's a complex tool and actually pretty resource heavy. So there's a lot of features on it that you can use to like figure out what kind of users you have, where they're coming from, what kind of devices they use. You can even figure out like the screen size, right? So in case anybody was curious what they're tracking when you go to any website that uses this tool, it's pretty in depth, kind of scary actually. So cleaning the data, NumPy and Pandas, which are Python libraries, those are basically, so Pandas are basically like if you take an Excel sheet, the data looks like an Excel sheet. It's tabular form, and so you can do it's very efficient in terms of dealing with lots of data. You could have like an array, but that's going to be very slow when you have like, a gigabyte worth of comma separated values or something like that. And you got to do the same operation for all of them. Storing the data, if this is something that you find interesting, and as BMIS like touches on these topics, understanding the differences and the trade-offs between the databases, that's actually like the most common interview question I get as like a software engineer. It's like, why would you use MongoDB versus BigQuery? Oh, well, because MongoDB is like easy to append to. Oh, because BigQuery can have relational things, stuff like that. So that's very useful to know. Again, you don't have to know, all of it, but if there's parts of this funnel that you like, oh, that's cool, I like that, I would urge you to do a deeper dive on it. And of course, the buzzwords these days, training ML models, right? We're talking about Llama, Gemini, Mixtral, some of the open source stuff. In the machine learning world, this is kind of the hot topic right now. And, there's, again, like the databases, there's trade-offs. Some of them are smaller. Some of them have like, 8 billion parameters that they're checking on, or 70 billion parameters. And those are going to run differently depending on even the hardware you're running it on. GPUs, NVIDIA GPUs, et cetera. But all those things, all those LLMs are only good as the data that you train it on. I'll repeat myself there. That's very important. Like ML models are only as good as the data you train it on. And so that's why the top parts of this funnel are really important, because eventually they get baked into these LLMs. And sometimes you can have pretty bad responses if you're training on bad data. Makes sense, right? Garbage in, garbage out. But those are also very time consuming and expensive to train ML models. That's why you don't see a lot of them that you see out there are trained by these massive corporations like Google or Meta or OpenAI. OpenAI, I guess, kind of a medium size now. But the reason for that is why not every machine learning engineer is training it on their, gaming PC. Like I tried to once. I found out the hard way that it takes a long time. You need a lot of data. Number one, like I said, ingredients. You need computing power, which is why NVIDIA is like through the roof in terms of stock, because all the hardware and all the libraries used to train the models are built by NVIDIA. And so I got my gaming computer here, a 3070 RTX, and like that's not even enough to do that, right? So so if you're a business, right, and you're looking at that and saying, well, how am I going to use an ML model? You know, we barely have software engineers, whatever. Well, you can go down the funnel here and say, okay, we're just going to use a base model and use fine tuning. What the fine tuning does is that given your use case, you can basically, a base model is kind of like kindergarten, where you're teaching a child like all the basic general knowledge, right? So elementary school, you're learning the basics that everybody's going to learn. That's what a base model is. Fine tuning is like, so what you all are doing, you're majoring in something, you're specializing and gathering knowledge that's specific to a domain, right? An English major is totally different from a business major versus a nursing major, right? You're specializing. What you're doing, you're basically fine tuning your brains. And then on top of that, you know, you have things like RAG models, which is like a database that will inject like parts of the database into the prompt itself, so that it's a kind of the easiest way to get a bunch of data into the prompt as context. Because again, like what you're really doing is just trying to give the LLM context to do a task. And so those are different techniques. Again, like as you go up, like the harder it is in terms of like resource wise, right? But and then after that, you have actionable data, right? So you're using things like tools like Tableau, Power BI. There's a whole bunch of other dashboarding tools out there too. Again, you're presenting that to the person, right? The user, you should always consider your user, right? What does the user want and need? And that's what the whole purpose of this whole thing is, right? Before you should build any of this, you should always ask, like, what does the user care about? That user could be someone using your website or whatever, or your service, or it could be your coworker or your manager, or, you know, at Google, a lot of what I was doing was internal. So a lot of the users were other software engineers or program managers that wanted to see certain results and data and metrics. And so that's what a lot of my work was. And so, I mean, I think from what the professor told me, you're using Python in this class. Python's king, all right? Like Python is the king right now. I think Dr. Trang, you said that there's a quote you said. I asked you in college, I said, what language should I learn? And then you said, it's not a religion. Don't get married to one idea. You should go with what's useful and for your use case, right? And luckily, it hasn't changed too much. It's still Python, given these last few years. It's just so versatile, right? It's so versatile in terms of industry and like places they use Python. So you can be a data scientist, you use Python, software engineer like myself, Python. At Google, the predominant language is Python. Next is Java, but I did some Java work, but man, it's all Python. Because even if you're using like a notebook, like a Jupyter notebook, it's all in Python. Automation, Python. And a reason for that is that the support and libraries that come with Python are so extensive and well managed in terms of upkeep. And you can go to like these GitHub repositories and see where the library and see how many people are contributing to this like open source tool. And it's really quite amazing. You go ask a question on Stack Overflow, I'll get a response for Python related stuff within like an hour because there's so many people using it. And so the versatility of it is just so like you can never go wrong learning Python in this world. Okay, so like it's going to be there to stay for some time, I think. And so popular libraries that are, you know, there's like, again, like a near infinite number of like libraries, but the real essentials that I would really urge is like scikit-learn is really good for like, it actually has many capabilities, right? You can visualize very easily. You can build these charts. You can also like test really rapidly in terms of your machine learning models. And there's many different like built-in functions too that make it really easy. Pandas, I think, work with scikit-learn and PyTorch as well. So PyTorch is kind of similar to scikit-learn, but PyTorch is more based. I think scikit-learn can also it can train the models themselves. I think I haven't done that specifically, but with PyTorch you can train the model itself and then distribute it. And then pandas are just kind of like the Excel sheet of the data engineering world, analysis world. Spreadsheets have their limit, and performing operations on them can be quite intensive. And so, and then if you have it in Python already, you can easily just have it interface with like BigQuery or AWS Redshift or whatever database you're using, MySQL. So those are just some. There's on the right here, you have Matplotlib for visualizations and others. TensorFlow and PyTorch are actually equivalent in a sense because they make use of the GPU. I decided to go with PyTorch just because from Reddit, a lot of people were saying that TensorFlow was kind of falling out of favor, but it's still well used though. Those are the two big for machine learning like deployments. Scikit-learn, of course, is going to give you like the before that, like the training and the visualization and the testing. It makes it really easy for that stuff. So yeah. Okay, I'll pick it up here. But again, we went over this a little bit here, the LLMs, the base model, fine tuning, and then like more kind of surface level like editing. It's more expensive when you have base models. Again, why Meta and Google are putting these things out, and then people are picking them up and then taking it on with fine tuning or prompt engineering. And RAG's a kind of a database based version of like that prompt level injection, which is quite useful because if the data is changing all the time, you can't retrain the model every 5 seconds. That's it's just infeasible. And so a RAG model would be great because it's just pulling from a database and putting it in the prompt as a context and then spitting out results. So that's cool for highly updating data. Now, some of the question here is like, we have so many models, which one do I use? There's a lot of tools out there that can actually do that. Like there's a leaderboard and this changes all the time. And so as they train new models, you get to see the kind of the compare them side to side. So there's plenty of things like that. Olam is another tool that's great because you can run the model locally on your machine, and then you can have multiple models running at the same time. And you can test them. Very useful tool. Resource intensive on your machine, depending on the model you use. Right, and so in this concept here applies to everything, and not just for people who want to get heavy into machine learning stuff, but just like in general, when you use any sort of technological concept. There's so many of everything that like you have to consider, like what do you consider, right? Cost and money in the GPU usage, obviously. The performance on the domain, like what is best for my use case. But one thing that's always like left out of the conversation is the ease of use of setup. A lot of people want to use the most complicated tool just to say that they can use it. That's not necessarily correct because in the business world, when you're learning it, that's awesome. That's great. If you know that, amazing. But the problem is that in the business world, you have a time limit and you have a money limit. And so sometimes going with the good enough situation is the best thing to do. That's what I learned at the startup. It's like, I want to be because at Google you code and you get nitpicked just for like having, you know, your styling is weird or whatever, right? At the startup, it's like, you just got to get this thing out. So there's kind of a way that for that specific use case. All right, for the future. So a lot of the, hold on here, before we dive into the future. So some of the biggest problems right now is like, on top of that funnel, you're getting so many data sources. How do you get them to work together? Because they're going to come in different formats. You're going to get CSV files. You're going to get a database. You're going to get like just random text. So the question is, how do you get that together? And so I've been reading some articles about like how they're using LLMs to merge that data together to normalize the data, to make it normalize, meaning like it's on the same. I'm using the sense that you're using it in the same, making two different data sources like compatible, like the same data types. Maybe the date looks funny, so it doesn't actually match up with the other date, so you have to like clean it that way. So a lot of those common things are stuff that you see in any sort of data concerned job. And the pace of everything is so crazy. One week I'll be like, oh, wow, like an LLM can do, you know, this. And then 1 week later, you know, my buddy will tell me like, oh, actually the same model you were looking at actually can do this now, or you can like recognize images now. Or so at the start, for example, there's actually 2 different models we kept juggling back and forth. And as engineers, they told us like, don't drop the code completely for this model because we might switch back to it, depending on how good it is in the future. So that's, you kind of have, it's so fast paced, you kind of have to have like a, you know, stream of information in terms of like what you're going to use today, you know, like, but that's just the world we live in. And so, you know, your MIS, your, you know, business folks, you're technologically sound, you know, more than most others. Yeah, as you come from this, like from your experience in college, you're gonna be looking for jobs. You know, I'm assuming majority of people are there for college looking for jobs. And one of the things I realized that is that the titles that you look for, and you when you go search for these jobs, and I want to be an X, I want to be a Y, I want to be a Z. You can kind of stretch it because you're in a spot where coming out of it, you're to be totally honest, you know, you're gonna have to do some still like you're always gonna keep learning. But the biggest question is, what direction do you want to keep learning in? And so you're coming from, you know, depending on what your kind of propensity is, I see people who in MIS who gain the skills, you know, because MIS puts a solid foundation for a lot of these things. You can become a data scientist, you can become a data engineer, machine learning engineer, and data analyst. When I was in MIS, I think a big focus on a lot of folks becoming like data analysts and kind of like very much on the cusp of technology and business. And some of the three first here are more like tech heavy stuff, and it's going to require more training. But you have a foundation for it coming out of like this class specifically. You know, you have the concepts, you have the stuff. You can extend yourself into these roles, which pay quite a bit. You know, and you know, don't be disappointed if you don't come into those roles like right away. Becoming a data analyst, understanding what that does, and then doing other things, and you know, eventually becoming to those roles is a totally acceptable way to plot your career. Again, like I didn't come out of college as a software engineer, like no way, not even close. But over time, I really like committed to, I want to get the experience. I spent a lot of my spare time like building little funny scripts and stuff and scraping websites, you know, and that kind of turned into, you know, and I talk about those things like in interviews, and those are totally valid. Like, yeah, I have experience with this, you know, technology because I went on my own, and that actually shows in self-initiative. So again, like there's so much to learn for each of these, but again, I think where you're at in this class gives you a foundation to go forward. And quick note too, these are very different from software engineers. Okay, so for example, we had a data scientist, machine learning engineer guy at the startup actually, and he writes Python code. But one of my jobs is actually to look at his Python code and to make it acceptable so we can put it into the code base. And he knows, you know, it's fine. There's nothing wrong with that because he comes from a machine learning engineer background where they write code in a specific way that is different. So my point here is that you don't have to be a software engineer to become a machine learning engineer. There's actually two different roles. And so don't think, I don't have what it takes to be a full-on software engineer. Well, you don't have to be. That's not what this is. This is a kind of a different role. So just don't let the word engineer, like, you know, push you away or intimidate you in a way. It's different. So now you're, you know, if you want to look for jobs and stuff, like what now? I gave a talk earlier in the year, like Dr. Trang mentioned. This lecture will go out to everybody, hopefully. So the link is here. Basically, how I was actually laid off from Google earlier in the year. Spent some time in this awful job market, looking for a job, and I was able to get the startup position. And so because I specifically wanted that experience, and you know, it's there's kind of new techniques I kind of come across that I was using that I didn't use before applying the jobs. So I shared those in this video. I won't get into that. We don't have time for that today, but basically, you know, trying to get those referrals, networking with people to get the referrals so that they can, because that will increase your position, your chances with a company 10 times, right? So, and then looking to see exactly the job descriptions and, you know, what you want to go for, stuff like that. The biggest thing is experience, right? I mean, you've probably been told this time and again, but you can also be creative in this field because conventionally internships, yes, internships, please, yes, and jobs and stuff, whatever you can get. We can also look into like open source projects. one of the ways that I got my start in software engineering is I go to like an open source library on GitHub and I look at their like bugs, basically a list of issues that need to be worked on. And so I would go and pick a few of those up, start commenting to, hey, what needs to be done here? Like, oh yeah. And so you get a good experience that way, working with in your technical field with other people on a technical level. But yeah, so projects, even as students get together, like, hey, there's a cool idea we can build a thing on. Yeah, we could do that, and then you can turn that into something that you can show employers. So yeah, so again, I just want to give you an idea of what I was working on in terms of like the tools and the techniques I was using in my jobs that I've held in the last like 8 years or so. Kind of the tools of the trade and what I think would be a good place to put yourself for the future. So again, my name is Xavier. There's a QR code for this presentation if you want it right now. But my LinkedIn is here, and any students of Dr. Chuang. I love helping. People have reached out to me in the past before, asked for referrals and stuff, and so it's been feel free to reach out. And if you want a quickest reply from me, it's just through my email, but you can add me on LinkedIn and look at my background on my personal portfolio. So yeah, so thank you for listening. I guess we can go into questions now.
Awesome. So it sounds like you touched on this in your previous talk, but if you could go back in time and give your senior in college self some advice about entering the career world, what would you say?
I'd say talk to more people about what they do. One thing that I would have done differently was like basically with a goal of what position do I want to end up as? Because the title I realize is when you're working for the company, like at Google, nobody cares about what your title was, right? Like my official title was like technical solutions consultant, which nobody knew what that was, even people at Google, because I was doing like software engineering work and program manager work, but it's like, what is a technical solutions consultant? Like people don't really, I think focusing on like the title that you want to have so that when you go look for a job, it'll say on the your resume, this is what I do. And then people automatically go, oh yeah, I know what that is. So I think talking to more people in terms of finding what title I want and the work I want, obviously. And so I could have done that, I think, better at Gonzaga. Just because like that kind of happened for me later, right after Gonzaga, where it's like, oh, I don't want to do the business side of things. I want to do more technological side of things. But I didn't necessarily have to go do like an entire internship for whatever thing I'm curious about. Maybe just going on LinkedIn, Gonzaga alumni are pretty nice, right? So like reaching out to them and saying, hey, like can you tell me about like what this role is like, and that sort of thing. Yeah. Good question. Any other questions?
I think most of you are graduating the next year, right? Yeah, you should have some questions.
Yeah, if you're graduating the next year or so, I would say like, you um just go look at what's out there in terms of available positions and get a feel for what there's many offerings for. I don't know, Dr. Chuang, if you feel this way still, but like, it was a tough job market earlier in the year. And then now I hear that it's lightening up, but with interest rates falling, I think we're on track to probably have companies have more capital to use for hiring people, which is my hope. So I think that it'll be looking up, fingers crossed.
I was curious, what is your opinion on using AI software to code?
Love it. I love it. I feel like in an academic setting, that might be a controversial statement. terms of my job, like, yeah, I welcome any help I can get, you know, like, I, it's so, some of them are getting so good, right? Like, it'll just predict like an entire page that I want to write, and then I'll hit it, and then I'll just edit it to fix the details. So like what, like precision rate being like 80% or something like that. It's pretty good. But that being said, like I think that's also going to stunt, like to give credit to the academic argument that it's going to stunt at like people's education in terms of the matter. Yeah, I think so. That's why it's important to actually turn it off. Like when I do elite code stuff, for example, which is like a practice for like technical interviews, I will turn it off so that it doesn't predict for me the algorithm that I need to write, you know, because it's actually gotten good to the point where it can actually answer the elite code questions pretty well. And so I don't want to do that. I need to learn it. And so I need to be self-disciplined in terms of turning it off. But in a place and time where you need every bit of help that you can get, yeah, I'm all for it. Yeah.
Are you nervous about jobs in this field being cut back or eliminated because of AI? And or do you think there'll always be a need for data scientists and engineers in the future?
Those are the roles that won't be cut back, actually, because those are the roles that are building these things. And for as much as the media touts them as these things that are just going to automate the whole world, I'm a skeptic to that, because I've seen how they can fail. And there's a lot of work to be done. And you know, I think it's, personally speaking, like when people are like, oh, it's going to become sentient, and I think at this point it's nonsense. It's just like, you know, you think something is so cool, and then you look on it on the inside, you know, and then you go, oh, this is just like rubber bands and duct tapes, you know, and so like you're you know, it's not as robust as people think, and there's still like downsides to it. So like data science, machine learning positions, I think are just kind of boom. I've seen tons of them. I had an interview actually just like last week for a machine learning engineer, and you know, the questions they were asking me were like, how well do you know PyTorch? How well do you, and then what algorithms would you use if you were to find the sentiment for like tweets or something like that, right? And so it's like, you know, I think that you still need people who know how to do that. But like, I think the jobs that would be getting automated a lot are anything where you're not really, you know, you're just kind of providing like a response to things that's like, basically anything like an LLM can do, like, I don't know, maybe copywriting, I guess, stuff like that. Like some of the analysis stuff, I think in the next few years, a lot of those things will either change or maybe cut back a little bit in terms of like, if only thing you're doing is just taking data and just reporting it or something like that. Like that's, you know, it's like, well, you know, but that's a good question to ask all the time when you look at positions. It's like, is this something that's going to be safe from this sort of thing? And even if it isn't, like, it's still good experience, right? So, yeah. It just depends on what you want, I guess. Like, oh, I need this job, but it requires this thing. Oh, I'll take this other job. They'll prepare me for it because it does like XYZ specific things. So that's a good way to go about it.
With your experience at JP Morgan, I imagine one of the biggest like challenges with that is the work-life balance. How does your experience with that compare to what you're doing now, and your ability to, you know, balance your work with your other interests?
Yeah, startups are kind of in the same way. They're very intensive, and they expect you to work many, not all the time. Google's on the other end of the spectrum where, you know, like they have nap pods, just to give you an idea of what that's like, right? And so it's like the culture is very cushy, but also they give you freedom in terms of like time when you work. So it's like, maybe I'm waiting on something or I can't solve something, so I'm gonna go for a walk or something and then come back, maybe, work on the same thing later that night and work on it. It's all up to you, which is great. That's what kind of like the way that I like to work. Yeah, JP Morgan was work-life balance is, again, it's not necessarily an objectively bad thing. It's just that for me personally, and for I think a lot of folks, it's just not for them. But if you're into that, like, and you get the capability and you really want to do that, then, yeah, just I think that's a good question to ask in an interview, for example. What's the work-life balance like? Am I going to be expected to work like outside of normal work hours? Totally valid, totally normal questions. And then you can use that answer as like a kind of to weigh your decision on what you want to go after. But you should tie that to the company culture itself and not necessarily titles. Yeah.
What was like the biggest upsides for working for a big corporation and working for a startup?
Yeah, okay. So working for a startup, pros and cons. Pros, you get to learn everything. And so like you just like, hey, we need this thing. I don't know how to do it, but I'll take it on since I'm probably the one who like would want to has any interest in this. Like a lot of like the startup at Delta, it's like deploying code, for example, like DevOps sort of work, like working with Docker and GitHub and creating like deploying it onto the Kubernetes machine, Kubernetes deployment. It's like I felt like I kind of like I've done that before, so like okay, I'll do that. But you kind of have to take a lot of initiative, and kind of seek work out for yourself, because if you don't, no one's gonna just sit there and assign it to you. Like so, like school is the opposite, where you sit there and the professor's like, here's the syllabus, do this list of stuff, and then you don't really have to think about the thing that you're going for. I mean, that's kind of why you're in school, right? But a skill that is kind of hard to acquire, and sorry if it's like loud outside, there's someone blowing leaves. But the skill that's hard to acquire is being able to take initiative on yourself and find the opportunities. And you kind of use like the entrepreneurial mindset you have, I guess, if you have one, to like look at what's out there and say, hey, what are the biggest problems we're facing and how do I go fix it? And that works at the startup. And that also works like at a corporation, like at Google. Like my team was very much like a startup. Like I kind of walk up to my manager and like, hey, I noticed that the latency for these features are like totally garbage. Like, what can we do about that? It's like, oh, well, that's a great point. That's one of our like company's initiatives this year. So, that's common, but the difference is like the resource too. So at a big corporation, if you don't like your role or your team or whatever, it's easier to move around, right? In a startup, there's 20 of you. So what team are you going to go to, or what team are you going to aspire to move to? It's like, if you want to do a startup, do it earlier in your career. So, because, you just have fewer commitments. But like, when I coast and I'm good and, in midlife, like big corporation, that's how I see it. Like, just because of the perks and benefits, and the pay, I think is there's a disparity in terms of pay as well. Big corporations pay more. But, working for a startup teaches you so much. And so I always push people to go do it, as long as you're able to. So yeah, does that answer your question?
Well, I suppose that you may have more questions, but unfortunately, the time's up. So, first of all, I would like to just give a word. Thank you. Next question, as he mentioned, you are welcome to contact him. I'll see you on Wednesday. Yeah, see you in a few minutes. Yeah, right.